All right, here's a question where you're asked to simplify this irrational expression. So for square roots, you're looking for two things inside the square root, and you can bring one out. And so maybe let's deal with each of the things separately. So according to that product rule, I can break up all the different factors inside there into their own square roots. And if we take a look at the k's, there's k to the 6th, which means I have 6 k's, right? And so for every 2 I have inside, I can bring one out. There's 2, I bring another one out. There's 3, bring another one out. So since there's 3 k's, I can call that k cubed. Okay, q's, same thing. I could write 8 q's, but hopefully you can see that you'd have 4 pairs that you could bring out. And so you'd have q to the 4th. Okay, and all of that isn't under radical anymore because it was under and I canceled it out and brought it out of the radical. So none of these letters are in a radical. But I still have the square root of 405 there. Now, one thing I would do is you try and break that down. And so it ends in a 5, so I know 5 will divide it into it evenly. So 5 into 405, I think goes 81 times. And 81 is a real nice number for us to use. So square root of 405 is the same as the square root of 81 times the square root of 5. And the square root of 81 is 9. And you could do that on your calculator if you need. 9 root 5, and then k cubed, q cubed. Now, I think in the answer key, they have something to do with absolute value. I'm not worried about that. I think with the, whoops, that should have been a 4. I'm not worried about the absolute value. If you come up with this, that's what I'm looking for. The other thing that they often do is they write this at the end. So you could write it as 9k cubed, q to the 4th, root 5. Okay?